hand over to the second keynote speaker, is Professor Jeffrey Sachs. Please, the floor is yours.
Good morning to everybody. Thank you for participating in the Low-Emissions Solutions Conference of the Sustainable Development Solutions Network. And I want to give special thanks to our host, the University Politécnica of Madrid, for having us here at this outstanding university and for the participation of the rector and the dean and the faculty members of the university and the students. Also, I want to give special thanks to our partner, Paolo Carnevale and the Fondazione N.A. Enrico Mattai, a wonderful partner of SDSN during this past year with its large expertise in energy and its large network of experts on the energy transition. Together, we have produced a roadmap document, which I hope all of you will have a chance to look at and benefit from, and to give responses, because this is a partnership that will continue in the future. Why have we assembled? We've assembled here because we need, in addition to the politics and the economics that the minister just spoke to us about, most of all, I believe, the technical expertise on how to make a successful energy transition to net zero carbon by 2050. Indeed, it's my own personal theory of change that the greatest obstacle that we face in the practical challenge of decarbonization is the challenge of knowledge of what to do. And so I would like to add a third E to your ethics and economics, and that is engineering, because I think that this is absolutely crucial. I've been coming to the Conference of the Parties year after year after year after year. We are the 25th meeting today. We have not yet turned the curve on decarbonization with a treaty that was signed in 1992 to stabilize greenhouse gas concentrations at a level that would avoid dangerous anthropogenic interference in the climate system. We failed to meet that goal because we already have dangerous anthropogenic interference in the climate system today. We're already at a level of damages on the order of $500 billion a year worldwide. So we have missed the original target. The backup target was set 23 years after the signing of the Framework Convention in the Paris Climate Agreement. It said that the nations of the world would act to keep warming to well below 2 degrees Celsius and aim to keep the warming below 1.5 degrees Celsius. The Intergovernmental Panel on Climate Change then issued an important report noting that there is a big difference of 1.5 degrees and 2 degrees. 2 degrees is vastly more costly and vastly more dangerous in setting off positive feedbacks that could lead to runaway catastrophes. And yet, this year, again, there will be an increase of emissions, as there has been for the past quarter century. We have not turned the curve yet. So we need to understand what is the problem here. And I think that there are 3 overwhelming problems, in fact, but I'm going to put the emphasis on the reason why we're here. One problem is simply the vested interests of the fossil fuel industry. I can certify that any country that has substantial fossil fuels is semi-insane in its politics. There's nothing like coal, oil, and gas to turn you crazy. If you have a lot of it, you end up with Donald Trump as president. That's the extreme form of craziness. We are a petrostate in the United States. Other countries that have a lot of fossil fuel are also beyond self-control. And so the greed of powerful lobbies in the United States, it's ExxonMobil, it's Chevron, ConocoPhillips, Koch Industries. This has determined our politics. It has completely corrupted our politics. And that resource curse is familiar around the world. Think of Saudi Arabia, think of Russia, but also think of Canada, think of Australia. Not one of these countries has self-control in its politics because the power of the lobbies dominates the politics. So that's a problem. The second problem is inertia. We have had a fossil fuel industry as the basis of the world economy for more than a century. And when you come into this building, the steam engine is in front. It is the iconic machine of the modern age. It was the greatest invention in modern history. It transformed the world, and it created the dangers of reliance on fossil fuels. That's our world economy. Primary energy comes from fossil fuel for more than 80% of the total worldwide energy needs. This is what engineers have been trained to do for generations. This is how our economies are structured, and we need to make a dramatic change. And simply inertia is a reality. Just like it is in the physical world, it is in the policy world as well. You only change through some kind of force, just like in Newtonian mechanics. We need to push from the existing way, which has been underway for more than a century. The third factor, though, is the one I want to emphasize, which is that you cannot make change unless you know what you're doing. You cannot make change without a plan. To make the energy transformation to get to zero by 2050, which is what is needed, even to have a 2/3 probability of staying below 1.5 degrees, and maybe it's not even that high a probability, given other evidence that we're in even worse shape than we think. You need a plan. Without a plan, there's not a hope. Economists cannot make a plan. I'm an economist. I can tell you, economists don't have a clue as to how the power grid works. Economists don't know what energy storage needs are. Economists don't know what the battery supply chain is for electric vehicles. Economists don't understand the options facing the steel industry or aviation or shipping. It's not our job. That's the job of engineers. And without engineering, this is impossible. Suppose that President Kennedy said, I recommend that we adopt the goal of, before this decade is out, of landing a man on the moon and returning him safely to the Earth, and doing it at least cost, so I'm going to appoint a commission of economists to get us to the moon. It would have led to some interesting journal articles, but I don't think anyone would have gone 6 feet off the ground. If you want to go to the moon, you better get NASA to hire engineers, because that's the story. And if you want to decarbonize the energy system, you better get the engineers. up front, because the engineers are the only ones in the world that have a clue as to how this can actually be done. And when I speak with engineers that are knowledgeable in this, within 5 minutes, I am fully satisfied that I'm in way over my head in terms of really understanding some of the key issues that need to be done. But I'm also absolutely convinced, in discussions with engineers for a quarter century, that there are pathways to success. In other words, that this is an achievable goal, that it is not even an especially costly goal, that as Chile is finding, it comes faster than you think, less costly than you think, more prudent for the country than you think, safer from a national security point of view than you think. Indeed, Chile, with the greatest solar power in the whole world, how could it be any other way than tapping the Atacama Desert and getting that to be the basis of the energy system rather than relying on natural gas from Argentina or Bolivia or some other place? I wouldn't do that. So I think tapping your own energy source is a wonderful thing to do. And that requires the engineering for how to do this. So the purpose of our meeting is to bring engineering more to the forefront of the COP process. There's too much diplomacy, too many lawyers, too much negotiating over words, too much negotiating over whether we're going to receive the document or welcome the document. That usually takes about a week to decide between those two words, and too little practicality of what to do. And the what to do is a set of complicated challenges. No country can do this on its own, first of all. No country has the technology alone to make the energy transformation. Chile, for example, can decarbonize the power grid on its own now, though using international technology, but it will not produce the electric vehicles for transport. Those will be produced someplace else. Chile is not a major producer of automobiles, especially not electric vehicles. So there will be a European or American or Chinese or other, or Korean or Japanese supply chain, and that will be part of Chile's solution. And then when it comes to other parts of the technological transformation, that will come from other global supply chains. So this is a tricky challenge for any individual country alone, because no country is the master of the future zero carbon energy technologies. And therefore the planning process is quite complicated. What can each country do on its own? What can it do in conjunction with neighbors? And what is the prospect for global technological change on batteries, on electric vehicles, on alternatives in steel or aviation or shipping or other areas that will be possible to take advantage of? We know a lot about the broad contours of decarbonizing by mid-century, so let me just say a quick word about that. To decarbonize by 2050, it means to build not one single new fossil fuel-based power generation facility, no more pipelines, no more fossil fuel development today. This is what is the real truth, because anything built today will need to be stranded before its useful life is over. It will be a lousy investment. This hasn't stopped massive new building of pipelines, exploration for deep sea oil, new coal-fired power plants throughout Asia, but it's all completely contrary to the global objectives if we do that. So the first rule is stop digging the hole deeper. The only useful investments now are clean energy. I commend Chile for having 97% of its new capacity as zero carbon energy, as an example. It should be for everybody exactly this principle. All new investments are in the direction of green. This is not quite true of automobiles, but by 2030, no new internal combustion engine light-duty vehicle should be sold anywhere in the world. We should be on an all-electric diet by then for our light-duty vehicles. Otherwise, decarbonization by 2050 is simply impossible. So one has to think backwards, given the time horizons of the lifespans of infrastructure, buildings, transport, other physical infrastructure, power plants, to make a plan between now and 2050 to phase out entirely the carbon-emitting parts of the energy system and to build only clean. What is clean in practice? It starts with the backbone of clean electricity. This is in every scenario that has been published in the last 5 years. It's 100% clean energy grid that is the core. That by itself eliminates a third of global emissions, roughly. A little bit less. But then with that, one can decarbonize transport. And transport for light-duty vehicles can be decarbonized through an all-electric fleet. When it comes to trucking, there are other options. And aviation and shipping, still other options. Basically, for each of these decarbonization challenges, there is a partial electrification pathway. For example, for short-haul aviation under an hour, many experts think that that can go electric. But for longer haul, that almost surely involves some kind of synthetic fuel that is manufactured with green energy. So synthetic aviation fuel, advanced biofuels, and so forth. For trucking, there are multiple options, from fuel cells to catenary lines for electrified trucks. And those are also essentially renewable energy based, either green chemistry using zero carbon power or direct electrification. Shipping, another difficult sector we'll talk about today, has options of hydrogen or ammonia or other fuel carriers, or direct combustion of hydrogen and so forth. So there are options that need to be considered. And the heavy energy-intensive industrial sectors, steel making, petrochemicals, cement, and a few others also need their solutions. These require engineering pathways, and they almost all require new R&D alongside deployment, learning by doing, scale economies, so that by 2050 we end up with a low-cost, efficient, zero-carbon world energy system. So the basic framework is rather well understood. Clean energy, electrify what you can, green chemistry for things that can't be electrified, quick transformation of the easier sectors, which is power generation, light-duty vehicles, and new buildings, and more complex solutions for the more difficult sectors, which include heavy freight, shipping, ocean shipping, aviation, and energy-intensive industries. The balance roughly is that 70% or so of the emissions today from energy are relatively straightforward technologically, and perhaps 25% to 30% are more difficult because they're in the harder sectors. There is no fundamental barrier for any sector, though, because every sector has a list of options. Much debated, and that's part of the debate that we are trying to propel through the Roadmap 2050 and through the meeting today and through follow-up processes that we will be having in the future. What is the role of economics in this? In my view, it is subsidiary to the discussion about the technological pathways. A carbon price without pathways is explosive. Chile saw this even with a tiny recommended increase of public transport costs. France saw this in the past year with a modest increase of transport costs that has led to unending protests that are roiling the streets of Paris again today. What the public wants to know is the pathway. They don't want to hear from economists that energy prices are going to be higher. They want to know, what does the future have in store for us? Why are you doing this? Why does this make sense? Why will this be achievable? How do we fit into a global scenario? How do we fit into a regional scenario? How much is this going to cost, broadly speaking? Economists cannot give those answers without the engineering guidelines. The good news is the costs are not likely to be that high, actually. All of the evidence is on the order of 1 to 2 percentage points of GDP per year between now and 2050. That's a good bargain for saving the planet. Many estimates suggest below 1% of output per year between now and 2050. In other words, the minister is right. This is a core ethical issue. Even if it were much more expensive than that, we would do this. But it's not likely to be more expensive than that once we know what we're doing and once we understand what we're doing. So the purpose, and I'll just conclude once again, is to help make a roadmap that can be useful for every country and, even more importantly, for every region. Because Chile should be part of a regional solution in South America. Spain's solution should be part of a regional solution that includes North Africa, Spain, and the European Union. Every region needs to cooperate because renewable energy needs to be traded over diverse geographical areas to handle the intermittency of renewable energy flows. So the larger the grid, the lower the cost, the lower the need of storage per unit capacity of the grid. So these are regional and ultimately global challenges. Our purpose is to help inform the global process. I can tell you how interested Secretary General Guterres is in our deliberations, and he was absolutely delighted with the Roadmap 2050 because he said this is what we need, and he asked for institutional strengthening to bring the engineering even more centrally into this process. So we're trying to respond with innovations on how the engineering voice can become even more important. I just appeal to the engineers to do more than say, well, there are 10 ways to do this, and we don't know. If the engineers don't know, the economists surely don't know. If the economists surely don't know, I can only tell you what the politicians know. And so we need answers. We're at the end of the line. We are not in a theoretical seminar. We are at 414 parts per million. We are at 1.2 degrees C warming compared to the pre-industrial level this year. We are on a path of catastrophe. And I would remind you that on May 25th, 1961, when President Kennedy said we should go to the moon and back within this decade, they didn't know how to do it. But President Kennedy knew that they could figure out how to do it. We can figure it out. Let's get to work. Thank you very much.